Okay, this is an example of how to simplify cube roots or radicals with cube roots. So you're given a problem, right? First thing you need is your list of cube roots. Now, if you don't have that memorized, come into Desmos and create it. Y is equal to X, and then I do Shift 6 to get the caret up there, and I do to the third power. So now I'm going to come over here to the cogwheel and create a table of values. So these over here on this right side, it's going to be a list of my perfect cubes. Okay, you can go up as high as you want. That's probably plenty. So the number we're looking for is 135. First of all, look in your list. Is 135 a perfect cube? No, it is not. Okay, it would be somewhere in between these two. So it is not a perfect cube, but are there factors? Are there numbers that multiply to equal 135 and one of them is a perfect cube? That's what we want to know. So you could do this a couple different ways. You could just randomly go through this list and start dividing 135 by 8, 135 by 27, 135 by 64, 135 by 125, and hope that one of those becomes a perfect cube. The other way you can do it is to come down here and create another list and say y is equal to the number you want to know about, 135, divided by x. Okay, and again, you're going to have to make this into a table. And click the table. So we clicked cogwheel and then table. And then now we're going to start making a list, and we're looking over here on the right side to see if there is one of those numbers that's a perfect cube. So 33, no, 27. Well, that sounds about right. Let's come back and look at our list. Yes, 27 is the cube of 3. 3 times 3 times 3 is 27. So 27 is a perfect cube, and it's matched with 5. That means 5 times 27 equals 135. So I can come over here and break this down to, always write your 3 when you're talking about cube roots, 5 and 27. And when the 27 comes out, what is it? It's 3, right? So the cube root of 27 is 3. So 3 cube roots of 5. Okay, so that's pretty simple, I think. Now let's see, what if it had variables with it? Let's see if there's an example of that. Blast. Nope, I see no problems with, well, if it had a variable, I'll just change the problem. Okay, we'll say, let's do another problem. So I'm going to change this to be not only 448, but x to the 4th and y to the 7th, okay? And it's all under the radical. So I'm just changing the problem so I can give you an example of this. So is 448 a perfect cube? Come over here in our list. Remember, we have 2 lists. One of them was looking about specifically 135. We can get rid of that. We don't care about that anymore. But here's our list of perfect cubes. 448, it would fall somewhere in here. So no, it is not a perfect cube. So we want to know factors of 448 that are perfect cubes. So we go to the second line and we type in y is equal to 448 divided by x. And we go to the cogwheel and we change to a table. And now we're going to come down our list here. So is 224 a perfect cube? No, that doesn't sound familiar. Decimal number, definitely not. Nope, nope, nope. Oh, 64. Let's go check to see if that's on our list. And indeed, 64 is a perfect cube of 4. Okay, so good. We like 64. 64 times 7. So I'm going to break this down over here to cube root of 64 and 7. And then when in doubt, just expand these out, okay? 1, 2, 3, 4. That's what x to the 4th means. 4x's multiplied together. So then that would mean 7y's multiplied together. 1, 2, 3, 4, 5, 6, 7. And we want groups of 3 for the variable. So take the cube root of 64. That comes out and it's 4, right? So we say this is equal to cube root, and we have 4. So that dealt with this. This came out. Cube root of, we're going to leave the 7 behind. Then we can circle groups of 3. So that's one group of 3. So we have x to the first power out here. Then how many y's? We have 3 and 2 sets of 3 groups of y's. So now I have a y to the second power, okay? And then what's left over? The 7 and an x and a y. And that is how you do that.